Welcome you all to my channel, and today we are going to see the MATLAB Simulink of partial shading PV array. So partial shading is a condition where a different irradiations are provided to PV array, and we are going to see the PV curve and IV curve of the partial shading condition. So for this I have taken two PV arrays, and the input to the PV array are irradiation and temperature, and the output is measured through this measurement port. The output we measure is the voltage, current, power, irradiation, temperature. So these two PV arrays are connected here in series, and a diode is connected across both the PV array, and this diode is called as bypass diode. And for input irradiation, I am using a step input for irradiation. So for the first PV array, the step input is 1000, final value 1000, which implies 1000 watts per meter square as the irradiation. And both the PV array are chosen with these block parameters. We have one parallel string and one series connected modules. The module chosen here is one Soltec 1 STH215P. So this module has an open circuit voltage of 36.3, the short circuit current of 7.84, and this is the plot for IV versus PV curve for different temperature 25 and 45 degree. So for 25 degree, the power current is 7.35, the voltage is 29, and for power for 25 degree it is 213.1. Okay, so this is the maximum power which we get for the 1000 watts irradiation. So for other irradiations, the power will be reduced according to that ratio how we reduce the irradiation. So here for the second cell, I'm using a irradiation of 500, which means the rating which we obtain for power and current will be half of that one which we obtain for 1000 watts. Okay, so here the output is connected to the current and voltage measurement, and this is connected to the workspace through the Simulink workspace block. We measure the voltage and current in the workspace, and we'll plot the graph of IV versus PV curve in the workspace. Okay, and here I use a controlled voltage source to measure this voltage of the series connected cell, and this controlled voltage source is connected with the input of the repeating sequence of this value, that is 36.3. Here is this open circuit voltage. Okay, so now let us run this simulation. So you can see that the output voltage is 36.76 for the first cell, whereas it has been reduced for the second cell. The power to also reduced according to the irradiation. And now let us see the IV curve. So for this I open the MATLAB command window, and I type this command plot voltage comma current. So this curve shows the irradiation current voltage curve for different irradiation. The first curve is for 1000 watts and second curve is for 500 watts. Okay, and to measure the voltage versus power, so power we measure by using this equation, power equal to voltage into current. Then we plot the voltage versus power curve. So this is the voltage versus power curve. So this first curve is for 500 watts. Okay, and the second curve where we obtain a maximum power is 213. This is for 1000 watts. Okay, so thank you all for watching this video.